An alternative to the inductive style ignition system we've been talking about is something called a CDI, or Capacitive Discharge Ignition System. You may be familiar with companies like M&W or MSD who manufacture and supply these systems. The idea here is that when we feed the primary voltage to the ignition coil, it acts as a step-up transformer and supplies a secondary voltage to the spark plug that's many times greater than what the input voltage was. Using the inductive system, we were supplying the battery voltage to the coil. Let's say that was 13 or 13.5 volts. It might have taken 2 or 3 milliseconds to charge the coil with voltage. If the battery voltage went down to, say, 8 volts, it might have taken 5, 6 or even 8 milliseconds to charge the coil. In a capacitive discharge ignition system, we have a capacitor storing up energy from the battery all the time. This allows us the ability to supply a primary voltage to the ignition coil in the order of 400 to 500 volts. As you can imagine, the actual time it takes to charge the coil to saturation point is much smaller. Therefore, we get two benefits. The energy to the spark plug is dramatically higher compared to an inductive ignition system. This means it's great for applications that will experience really high cylinder pressures, setups with high compression, nitrous oxide, turbocharged or supercharged applications. Each of these power adders make it difficult for the spark plug to fire under compression in the cylinder and can benefit from this high spark energy. The other benefit is that when we're working with engines that operate at really high engine RPM, the amount of available coil charge time gets smaller and smaller as the RPM increases. By supplying this high primary voltage to the coil and dramatically reducing the charge time, we're able to charge, fire, and recharge our ignition system much faster than we ever could with an inductive ignition system.